Okay, so can anyone confirm if the screen is visible to you?
Yes, sir. Visible, sir.
All right, so let's get started then. Okay, so the coming to the first question for today's assignment. So if a graph G is given, so what will the following code snippet return? So you have the first line, uh, values nx dot degree g dot values x equal to 0, and then you have this loop for value in value if x less than value x equal to value, and then return x. So let us understand this code line by line and what it does. So this first statement, this is call it line 1. So what it does is value is equal to nx dot degree g. So g is the given graph, and what you are taking is the values of the graph. So what this returns is a list of degrees of each node in G. So values is basically a list of uh, the degrees of the nodes in the graph. Then you have x equal to 0. So now degrees can only be 0 or positive, cannot be negative. So degree
So
is
screen not
always
visible, sir.
uh, is the screen not visible? Wait, let me check. Can someone else also confirm?
The screen is visible, but the display width is quite low. So,
Is it small? Uh,
yeah, now it is better. Yeah.
okay. So, okay, so I'll start again. So if you have this graph G, what would the following code snippet return? So you have values equal to nx dot degree G dot values, then x equal to 0, and then you have this loop, and then finally return x. So we'll try to understand this code line by line. So what the first line does, line 1 does, is values equal to nx dot degree G dot values. What this does is it returns a list of degrees of each node in G. So degree is basically the number of uh, neighbors of a node. So degree can only be non-negative. So degree is greater than equal to 0. So the next, coming to the next line, x equal to 0, line 2. So this is just an initiation. Uh, Now coming to the loop, what it does is taking for value in values. Remember, this values is a list. So it contains the list of degrees. And then for every element value in this list, what it does is checking if x less than value, then update x equal to value. So what this line does is basically it is selecting the maximum value from this list. So it is taking the max of the values from this list. So, and what does this list contain? It contains degrees. So basically, the right answer would be returns the maximum degree of the graph, because this list is storing the degrees of each of the node in the graph. Is it clear? If you have any question, you can ask now or maybe at the end. Uh, all right then. So this is question.
Sir,
Yeah, go ahead.
sir, can you please repeat this again? I can understand.
Which part you missed? Like
Actually, uh, first line. What is degree actually?
degree is the number of neighbors of a node in a graph. So like if you have this graph like this, 1, 2, 3, 4, and I draw edges between them. Let's say like this and name it 1, 2, 3, 4. So degree is basically the number of neighbors. So degree of 4 is how much? 2. So because it has two neighbors, 2 and 3. So degree of 4 is 2. So degree basically means the number of neighbors of a given node. And what this line does is it taking degree dot g and dot value. So it gives the list of degrees of each of the node. So for this graph, so it will return the list like this. So for node 1, degree is 1. Node 2, degree is 1. For node 3, degree is 2. And for node 4, degree is 2. So the first line will return something like this for this particular graph G. Is it clear now?
Yes, sir, I got it.
Okay, so the next lines are pretty easy to follow, I guess. It's basically selecting the maximum values from the list. So it just, if it's looking for a higher value, it's updating the value. So that is just selecting the maximum from the list. So that is how it returns the maximum degree of the graph. Okay, so let us proceed to the next question. Question number 2. So, okay. So what is the density of the given graph? So you have this graph, you have 4 nodes. So A, B, C, and D, and this is the graph. So what density means? So density equal to number of edges present by number of all possible edges. So in a graph of n nodes, the possible all possible edges equal to the total number of possible edges equal to n choose 2 or n into n minus 1 over 2. Okay, so in this formula, in this given graph, uh, what is the density? Is the total number of edges present. So if you count, there are 4 edges present, and in a graph of 4 nodes, the total possible number of edges would be 4 choose 2. So that would be equal to 4 into 4 into 3 by 2. That is equal to 4 by 6, and that is 2 by 3. So this is the density of the given graph. Is this clear?
Yes, sir.
All right, then we can proceed. The next question is someone in the chat box has asked to repeat question 1. I'll repeat the questions at the end of the lecture. So right now I'll proceed on to question 3. So if you are about till the end of the lecture, I'll repeat it once again. So uh, now let us proceed to question number 3. Okay. So for a given graph A, equal to, for a given graph, if A equal to the ratio of highest degree to the total sum of degree, what will be the value of A? So for this given graph, you have this graph with 5 nodes. So highest degree, again, degree is basically, so like I mentioned, degree is the number of neighbors. So in this graph, we have 5 nodes. So let us find the degree of each of this node. So we have node A, node B, node C, node D, and E. And what is the degree of A? A has only one neighbor, so 1. B has 3 neighbors, so 3. C has 2 neighbors. D has 2 neighbors. E has 2 neighbors. So the highest is 3. So now we'll have to find this A equal to highest degree by sum of degree. Now this quantity sum of degree, how do we find this? So we can mechanically add all the degree, but there's a simple formulation. That is basically if you are adding the degrees of all the nodes, what you are basically doing is counting the number of edges that is uh, connected to that node. So for if we look at B, what you are counting is this, and this. So thrice. But when you are going to D, again what you are doing is you are counting edges, uh, this and this. So you're counting this edge BD twice. So basically, if you sum the degree over all the nodes, you're counting the edges twice. So this sum of degree is nothing but twice the number of edges present in the graph. So in this case, how many edges are there? So you have 1, 2, 3, 4, 5. So basically this quantity is 2 into 5 equal to 10. So therefore A is equal to 3 by 10. So this is the right answer, D. Is this clear? If any doubt, you can ask now, or maybe we can answer at the end.
So how the highest degree of A will be 3?
Highest degree of A is not okay. So there's a problem with this question. So this A and this A are different. So don't confuse with that. So A is a variable, which is basically the ratio of highest degree by sum of degree. And this A is a node in the graph. So for finding that for the highest degree, we found out the degrees of all the nodes, and we find that node B has the highest degree, that is 3, and sum of degrees twice the number of edges, that is 10. So the ratio is 3 by 10.
Okay, sir. So the summation of the degree of 2E, is it a formula?
Yeah, so it will
2
always be
modulus.
twice the number of edges because you're counting the edges twice. So basically degree of one node is the sum of is the total number of edges connected to that node. And if you sum over all the nodes, you are counting every edge twice. That's why twice the total number of edges in the graph.
Okay, sir. Thank you.
Okay. Uh, Yeah, someone has asked that we can also add the number of edges for the degree. Yeah, so this is a small graph and you can do that. But if there is a large graph given, so finding the total number of, if you sum over the degree, that would be very cumbersome. So it is much easier to know what is the total number of edges. So you can write one line commands and get it and just multiply it too. Anything that works will do. Okay. Okay. So let us move on to the next question then. Uh, um, Coming to question number 4. Which of the following is an example of a directed graph. So you have four options: network of Instagram followers, ancestral tree, email network, or road network. So now consider what is a directed graph. So directed graph means that there is, if there is edge between nodes Vi and Vj, uh, it does not imply that edge exists between Vj and Vi. So if Vi is somehow connected to Vj, it does not mean that Vj is connected to Vi. So in such cases, we use a directed graph. So yeah, so let us consider the first example. So that will make things clearer. So first is network of Instagram followers. So if I assume most of you are aware of how Instagram works. So if in Instagram, if you follow someone, it does not imply that the other person follows you back. So if by following someone, it means that there exists an edge from, let's say, you are I and someone is J. So you follow someone. So follow. It does not imply there also exists an edge from J to I. So this is not implied. So this is why it is a directed graph. Coming to the ancestral tree problem. So if an ancestral tree, it basically means that there's a father, there is a daughter, but it does not imply that it implies that this is the child, the daughter is the child of the father, but it we cannot draw an similar edge from daughter to father saying that the father is also the child of the daughter. So this is wrong. So ancestral tree are only directed uh, from a previous generation to the next generation. So this is also a directed graph. Coming to the third example, email network. Again, if you send from I to J, you send an email to J from I, it does not mean that J also sends an email back to I. So this is also an example of a directed graph. And coming to the finally the road network. So in this problem, it is assumed that suppose you have a city I. So let me write it. Uh, you have city I and city J. So if there is a road from city I to city J, it also implies
We can't hear you.
yeah. I'm sorry, I got muted. So is it audible now?
Yes, sir.
Okay. Can someone tell where we lost, so I can repeat that part again.
So from the road network example.
All right. So in this road network example, consider there is a city I and a city J. So it means that if there is a road from city I to city J, it also implies that there is a road from city J to city I. So you can ask that it may not always be possible that in case of one-way roads, but for our example, we are considering simple road network where if there exists a road from I to J, it also exists from J to I, like let's say a road for pedestrians. So in such cases, this road network is undirected. So for this example, the right answers are 1, 2, 3. So now coming ahead, adding one more question to the already existing question. So if there is for question one, the option one, so network of Instagram followers, if we replace Instagram followers with Facebook friend, what do you think? It would be a undirected or a directed graph? Can anyone answer? Someone has said directed. Anyone, any guesses?
Directed.
Uh,
Undirected graph.
why do you think it would be undirected?
Because
Oh,
road
yeah,
because road
one minute.
consists of n number of edges and n number of nodes, so it is the undirected graph.
Okay, any someone try again explaining? Uh, any more answers?
Sir, on Facebook, one friend will be a friend to another friend. So similarly, that friend will also be friend to another friend. So it will be undirected.
Yeah, you are right. So that is the reason. So unlike Instagram, if you send a follow request to someone, it need not be that the other person follows you back. So you may just be following them. But in Facebook, if you are friend with, if I is friend with J, then J is also friend with I. So this would be an undirected graph. So, okay. So this was question 4. Okay. So let us move on to the next question, question 5. So if X, is there any question? Okay. Let us start with question 5. If X equal to the ratio of clustering coefficient of node E by the clustering coefficient of node F in the given graph, then what is the value of X? So what is clustering coefficient means? So clustering coefficient is basically is a measure of how tightly knit how tightly knit uh, the neighbors of a node are. So the mathematical formula for clustering coefficient is the ratio of edges among neighbors by possible edges among neighbors. So what does it intuitively mean? It intuitively means how well connected your friends are. So in a social network, it basically means that the friend group that you belong, how well connected that group is, or how sparsely connected that group is. So here clustering coefficient of E. So let us call it CC for abbreviation. So clustering coefficient of E. So the neighbors of E The neighbors of E are F, D, and B. So you have three neighbors. So the total number of edges between them is basically 1. So only F and D are connected. There is no connection between F and B and F and D. So the clustering coefficient is total number of edges among neighbors, that is 1, over possible number of edges among the neighbors. So they have 3 nodes, so it's basically 3C2. So it's 3 basically. So 1 over 3. And clustering coefficient of F, if we take a look at node F, so node F neighbors are E and D, and two neighbors. The possible number of edges between them is only 1, because E and D two nodes, only one edge is possible in this undirected graph. So the clustering coefficient is 1 over 1 equal to 1. So X is basically CCE over CCF is 1 by 3 over 1 equal to 1 by 3. So this is the clustering coefficient. So if anyone has a doubt regarding this problem, you can ask.
Can you please repeat it again?
Okay, so you understood what clustering coefficient means.
Yes, sir. Yes, sir.
So it basically is the measure of how tightly knit the neighbors are. So it's the ratio of the number of edges among neighbors and possible number of edges among neighbors. So possible means all possible. So if we look at clustering coefficient of E, so neighbors of E are what? F, D, and B. So there are three neighbors. Now look at only these three nodes. How many edge exist among these three nodes? Only one, between F and D. So, and how many total possible can exist? 3. So in a fully connected graph consisting of F, B, and D, there can be a total of 3 edges, but only one is present. So the clustering coefficient is 1 over 3 for E, and clustering coefficient of F, if we consider, look at F, so this neighbors are E and D. Now look only at E and D. How many edges can be possible between E and D? 1. And how many are present? Also 1. So it's 1 over 1 and X equal to this. They wanted to find this ratio, which is 1 by 3. Is it clear? I hope it's clear to you. Okay, then let us move on to the next question. Question number 6. So it's which of the following is or are network dataset format? So you have graph ML, Tajik net, and CSV or comma separated value. So as we know, they all three are dataset format. So the right answer would be 1, 2, and 3. All of them are a valid network dataset format. So there is nothing much to discuss in question 6. So let us move on to question 7. So in question 7, you have a graph where nodes represents words in a dictionary, and there is an edge between two nodes. If two words are synonymous, then choose the correct option. So you have two statements. The graph is connected, and statement 2, if word A is connected to B and B is connected to C, then A is synonymous to C. Now let us study statement 2 first. Statement 2, what does statement 2 means? That A and B, there is an edge. It means that A and B are synonymous. So I'm writing equal to. So this means synonymous. So they mean the synonymous means two words having the same meaning. So they are saying that, okay, in a graph A and B are connected, it means A and B have the same meaning. Again, if B and C are connected, it means that B and C have the same meaning. Since the meaning of C is the same as meaning of B, and from this first result we have the meaning of B is the same as meaning of B, so we can say that meaning of A and meaning of C are also same. So this implies there exists an edge between A and C. So statement 2 is correct. So if word A is connected to B and B is connected,
You're muted again.
uh, all right. So where have I lost? Can you point out? Am I
After
audible?
statement,
So statement 2 was audible, right?
yes, sir.
Okay, so let us consider statement 1. Statement 1 is saying that the graph G is connected. It means that there exists some word A and any other word J. So there always exists a path from A to J. So suppose a path like this exists. So A is connected to B, to F, to K, to J. It means that the A and B are synonymous, B and F are synonymous, F and K are synonymous, and K and J are synonymous. It means A and J are also synonymous. So if statement 1 was supposed to be correct, then every word in the dictionary is the same as every other word in the dictionary, which we know is not possible. So this statement 1 is incorrect. So the correct option is D. Statement 1 is incorrect and statement 2 is correct. Is there a doubt? You can ask. All right, then. I guess you don't have a doubt. So let us move on to the eighth question, which is what is the diameter of the given graph G? So diameter, what the def is someone asking anything? Uh, all right. Okay. So diameter is the longest path in a graph. So what is the longest path in a graph? So given the nodes, which between two nodes that always exists a path, but which of them is the longest? So that is the diameter.
हेलो
Is there a question?
हाँ सर मैं अभी आया हूँ बस ड्यूटी से
Yeah. Okay. You have any doubt?
हाँ जी
Do you have any doubt in
और
the
सब चल
question?
रही
Can you repeat?
अच्छा नहीं सर बस अब तो ए, अच्छा अच्छा अच्छा
We're not able to hear you again. We're not able to hear you.
Is it audible now?
Yeah, now it is audible. Yeah.
Okay, so diameter is basically the longest path in a graph. So you have this nodes in a graph. So there could be a path from, let's say, F to D. So this is one hop path. So path here means number of hops. Or if it is a weighted graph, then it could be the length. So since this is an unweighted graph, so we are considering only hops. So let's say between F to D, path length is 1. From F, let's say from D to B, the path length would be 1, 2, 3. So this is 1, 2, 3. So it could be DB equal to 3. So now that for diameter, we have to find the path which is the longest. So if you look at the graph, it's basically from, if you consider go from E to B. So from, you have to go from E to B, you'll have to go E to D, D to A to C, and C to B. So that is how many hops? That is 1, 2, 3, 4. So is there a, do you see any path between any two pair of nodes that is more than 4 over here? So I guess not. So the right answer is 4. So that is the diameter of the graph. Okay. This was a simple question. So coming to question 9. So if there exists n nodes with no edges initially, then what is the probability of node V being isolated after including n log n edges uniformly at random? So now to solve this question, so first let us not look at n log n. Let us consider a graph. So let's say this is a graph. Okay, so let's say this node is V and the others um, are some other nodes. So what they're saying that if you insert U V being isolated, what does that mean? It means that there is no edge that connects to V. So V being isolated means no edge to V. So let us, if we were to see what is that, so now there can be, so these are the possible number of edges. So it could be this, 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 this. Okay. So these are the all possible number of edges that can exist, but we'll have to generate a, an edge at random. So suppose we we'll have to generate an edge without, we cannot pick these, we cannot we cannot pick these nodes. So these are the ones that connect to V. We cannot pick these. We'll have to pick the other nodes. So let us first do the simple case that, so how many total number of nodes? Edges, sorry, is n into n minus 1 by 2. And how many edges connect to V? That is n minus 1. So total number of edges not connected to V is basically n into n minus 1 by 2 minus n minus 1. So this is basically n minus 1 into n minus 2 over 2. So this is the number of edges not connected to V. So now we'll have to, let us consider probability of picking one edge that is not connected to V. Basically, so we'll have to pick this number of edges. So n into n minus 2 by 2. And how many total we could have picked was n into n minus 1 by 2. So this is n minus 2 by n. So this is the probability of uh, generating one edge not connected to V. So that is n minus 2 by n. Now we are considering an independent event. So again, let's say we generate another edge that is not connected to V. We are assuming it is independent of the first step. So in this way, so probability of generating k edges not connected to V would be basically n minus 2 by n over k. So this is the probability. Now, so the probability is n minus 2 over n by k, that is 1 by n by 2 over k. Now k is equal to n log n. So probability equal to 1 minus 1 over n by 2 n log n. Now if n is very large, if n is very, very large, probability is will be, so we can write it like this. So into 2 log n, and this term for large n would become e. So this term for large n is basically, it is e to the power uh, it is e to the power minus 1. So this term, and then you have to the power 2 log n. So if we take it, it is 1 by e to the power log n whole square, that is 1 by n square. So 1 by n square is the probability of V being isolated after adding n log n edges uniformly at random where n is large, then the answer is D, option D. Oh, is this clear? If you have any doubt, you can ask like how this derivation came. All right then. So let us proceed to question number 10. So question number 10 is basically choose the dataset format which starts with the keyword graph. You have GML, Graph Exchange XML, Project Net format, and GXF, which is basically the same as B. So D and B are the same thing. So the right answer is GML. It's called Graph Modeling Language, and it looks something like this. So you start with this keyword graph. Small graph, and let's say like this. So here you include node. You include nodes, and then you have edges, edge. You include source and target. So it looks something like this. So the right answer would be GML, Graph Modeling Language. So these were the 10 questions that we discussed today. So we don't have any more questions to discuss. So if you have your doubts, you can ask them now about any questions. So if you have come late and want me to repeat it,
Would you cover week 3 also?
Can you repeat once again?
No, would you cover week 3 questions also today?
No, we'll do that next week.
Sir,
Only week 2.
Yeah, so we are getting off. I think maybe we want to reconsider because the assignment was due last week. So this session would have been useful because we would have been able to do the assignment. So at least if tomorrow we can cover week 3, then we can catch up.
Oh, okay. I'll tell the other TA that is, I won't be the TA for tomorrow, so I'll tell the other TA to cover week 3 for tomorrow.
So then, we can look at week 4 for next week because see, every Wednesday our assignments are due. So that way,
Okay.
Monday is actually a very good day because we can, we would have done something. We can ask questions, get clarifications, and finish the rest of the assignments.
Oh, okay. I'll do that. I'll tell the other TA. So then, okay. So so this Monday you would ideally wanted to have covered week 3, right?
Yes, because week 3, the assignment is due on 15th. That is day after
Okay.
tomorrow. So similarly, week 4 assignment is due on 22nd. So 20th, next Monday, we can have discussion on week 4 because people would have studied week 4, might have attempted some questions, some assignments, so they may have some questions, and this session.
Okay, we'll take that feedback and okay. So next week, then I'll try to cover week 4 as well. So I'll tell the TA to cover week 3 tomorrow, and we'll look into week 4 next Monday. So I think that would be helpful for you people. Okay, so someone has asked to repeat question 1, 2, and 9 again. So okay, I'll repeat question 1. So it's given that for a graph G, what would the following code snippet return? So the first line says values equal to nx dot degree g dot values, x equal to 0. Then you have this loop for value in values. If x less than value, you update x equal to value and you return x. So what this first line is doing is degree dot values, it returns a list of degrees of each node in G. So if you consider this graph over here G, so you have 4 nodes 1, 2, 3, 4. Degree basically is the number of neighbors of a particular node. So the degree of node 1 is 1 because 1 has only one neighbor, that is 3. 2 degrees 1 because 2's neighbor, you have only one neighbor, that is 4. Degree of 3 is 2. It has two neighbors, 1 and 4. And same goes for 4. It has two neighbors, 2 and 3. So the degree is 2. So this first line returns a list that looks something like this if the graph was as I have shown over here. So then degree is, since degree is the number of neighboring node, it can never be negative. It's only greater than equal to 0. So in that case, for value and values, what it's doing is it's looking that if x is less than value, it is updating value. So what it's doing is getting a higher, it's checking for a higher value in the list, it's updating. So what basically it does is find the maximum in the list and then returns it. So it returns the maximum degree of the graph because the list contains the degree of the nodes in the graph, and this loop picks out the maximum. So the right answer is option D. Okay. Question 2 is what is the density of the given graph? So density is basically the total, is the number of edges present in the graph divided by the total possible edges that could have existed in the graph. So it is some density is a number between 0 and 1. So density can lie between 0 and 1. So in this graph, how many edges are there? 1, 2, 3, 4. So you have 4 edges and all possible edges. So you have n number of nodes. So all possible edges is 4 choose 2, which is 4 into 3 divided by 2, which is 6. And you have the ratio 2 by 3. So the density of the given graph is 2 by 3. So this was question 2. And moving on to question 9. Okay, question 9, it says that if there exists n nodes with no edges initially, what is the probability of node V being isolated after including n log n edges uniformly at random? So what does V being isolated means is that there is no edge to the node V. So you have this graph over here. V is at the center, and you have all the other adjacent nodes. So the total possible number of nodes would be n into n minus 1 by 2, that is n choose 2. But you'll have to generate a edge in this network in a way such that it does not connect to V. So number of edges that are connected to V is n minus 1. So we'll have to pick an edge excluding this n minus 1. So we have n into n minus 1 over 2 minus n minus 1. So that is equal to n minus 1 into n minus 2 over 2. So the probability of picking one edge that is not connected to V. So we'll have to pick among this n minus 1 into n minus 2 by 2. So we'll have to pick a node in such edge in such a way that it lies among these many number of edges and divide by the total number of edges. So the probability is basically n minus 2 by n. So the probability of generating one edge not connected to V equal to n minus 2 over n, and probability of generating k edges not connected to V is n minus 2 over n to the power k. We are considering independent events, so one event is not related to the other. So the total probability is n minus 2 over n to the power k, and if k is n log n, so you get this formula 1 minus 1 by n by 2 to the power n log n, and if n is very large, so you can do some modification. So it comes as this quantity to the power 2 log n. Now this quantity is e to the power -1 if n is very large, and then you do some algebraic manipulation and it comes out to be 1 over n square. So the right answer is 1 over n square. Okay, so I have discussed the 3 questions. Yeah, go ahead.
Thank you, sir. Okay.
All right. So if anyone else have any other question, you can ask. You can mention in the chat box if you have any question. Okay, there seems to be no more question, I guess. So then we can close the session for today. If there are any, if no one has any more questions, so we'll meet again next week, and we'll hopefully try to cover week 4, as someone pointed out that it helps you to solve the assignments better. So okay, we'll meet next week, and thank you again for taking the time to join this tutorial session, and all the best for the course. So you can start leaving if you want.